Hey friends, welcome back to The Skeptical Engineer. If you've been on my channel before, you know for most of my life I rejected the idea of God. Not because I disliked religion, I simply wasn't convinced by the evidence. And as an engineer for more than 45 years, I learned a principle that served me extremely well. Never invoke intelligence when natural processes adequately explain what you observe. If gravity explains the motion of a planet, you don't need angels pushing it. If chemistry explains a reaction, you don't invent invisible forces. Good engineering prefers the simplest adequate explanation, and that principle shaped my worldview for decades. But eventually, I realized I might have been asking the wrong question. Instead of asking, does God exist? I started asking something very different. If you had to create a universe, what would actually be required? And I want to take you through that thought experiment. For a few minutes now, let's forget every religion, forget the Bible, forget Christianity, forget every image you ever had of God. Let's approach this the way engineers approach difficult problems. Suppose someone hands you a blank sheet of paper and says, design reality. Where would you begin? An engineer doesn't start with a finished product. If you're reverse engineering a computer, you don't begin with the screen. You start digging the processor, the logic circuits, the transistors, the semiconductor physics. You keep going until you reach the most fundamental level you can find. And modern physics has done something remarkably similar. Physicists have kept digging beneath ordinary matter, beneath atoms, beneath familiar mechanical explanations, and one of the deepest, most successful descriptions we've discovered is quantum mechanics. But what physicists found there wasn't what everyday intuition prepared us for. Before we go any further, let's make the thought experiment more demanding. Imagine you're not simply building a machine, you're building an entire universe. You don't get to assume gravity. You don't get to assume electromagnetism. You don't get to assume atoms. You don't even get to assume space and time. You have to establish the rules that make all of those things possible. So the question becomes, what would you actually have to specify? And this is where things get very interesting. Think about what happens when you reverse engineer a complicated system. You eventually discover that the visible behavior depends upon deeper layers of organization. The screen depends on software. The software depends on hardware. The hardware depends on semiconductor physics. And semiconductor physics depends on deeper physical laws. So if we keep digging into reality, where do we eventually arrive? Quantum mechanics takes us to a strange place. Matter isn't simply made of little billiard balls. Electrons aren't tiny planets orbiting nuclei. Particles exhibit wave-like behavior. Every particle is described by a quantum state. Interactions are governed by mathematical operators, and the probabilities of experimental outcomes are calculated using mathematical equations. The deeper physicists have looked, the less the universe has resembled a simple machine made of pieces of matter, and the more it has resembled an astonishing mathematical structure. Here's what really caught my attention. Reality is profoundly mathematical, not approximately, not poetically, but literally. The equations of physics don't merely provide a loose description of what happens. They make extraordinary, precise predictions about what nature will do. Quantum mechanics has been tested again and again with astonishing accuracy. The same mathematical framework works across experiments conducted in different laboratories at different times and under different conditions. That mathematical consistency is remarkable, and it raises a question that physics itself doesn't necessarily answer. Because quantum mechanics can tell us how matter behaves, it can tell us how particles interact, it can tell us how quantum states evolve. But there's a deeper question. Why do these laws exist at all? Physics begins with the laws. It doesn't necessarily explain their ultimate origin. And that's where I found myself asking a different question. Imagine there is no universe, no matter, no energy, no space, no time. What has to exist before anything else can? Before there can be stars, there must be gravity. Before there can be chemistry, there must be electromagnetism. Before there can be atoms, there must be quantum fields. And before there can be physics as we know it, there have to be mathematical relationships that define how physical reality behaves. Those relationships aren't physical objects. They're not made of atoms. They're not sitting somewhere in space, and yet somehow governing everything that exists. So where do they come from? That's a very different question from asking how the universe works. It's asking why there is a universe capable of working according to elegant mathematical rules in the first place. This distinction became increasingly important to me. Suppose we could somehow remove everything physical. No stars, no planets, no atoms, no particles, no space, no time. Could you still have mathematical relationships? Could you still have logical truths? Could you still have the relationships that define what a possible universe could be? I'm not claiming we know the answer. We don't. But the question exposes something fascinating. The physical universe appears to operate within a framework of mathematical relationships, and those relationships aren't themselves pieces of matter. That means we may have to distinguish between physical stuff of reality and the abstract structure that governs that physical stuff. And as an engineer, that immediately reminded me of something I had dealt with my entire career. Information. Information software isn't physical in the same sense silicon is. The code is information. The hardware expresses that information. A blueprint is information. The steel doesn't invent the blueprint. The blueprint organizes the steel. An equation is information, and the physical system behaves according to the relationship expressed by that equation. Now, I'm not saying the universe is literally a computer. That's a much stronger claim. I'm making a more modest observation. Information, structure, and mathematical relationships can exist as descriptions or patterns that aren't identical to the physical objects they express. And the more I reflected on that, the more I wondered, maybe the deepest level of reality isn't simply matter. Maybe reality is deeply characterized by organized mathematical structure. But that immediately creates another problem. Where did that structure come from? Now, let me be careful here. I'm not saying quantum mechanics proves God. It doesn't. I'm also not arguing that consciousness somehow causes quantum events. Most physicists don't believe that, and the evidence doesn't require it. What I'm saying is much more modest. Quantum mechanics reveals a universe governed by extraordinarily precise mathematical laws, and that naturally raises the question, where did those laws come from? Whenever we encounter highly organized information, what is its known source? Computer software, engineering specifications, languages, scientific theories, mathematical formulations. In every case where we know the origin, intelligent minds are involved in creating or formulating that information. Now, information also appears throughout nature. DNA contains information. Crystals form intricate patterns. Snowflakes develop beautiful symmetry. But there's an important distinction. Those natural examples operate within physical laws that already exist. A snowflake doesn't explain why the laws governing molecular bonding exist. DNA doesn't explain why chemistry works. A crystal doesn't explain why the electromagnetic force has the properties it does. So the question isn't simply, where does information arise inside the universe? The deeper question is, Why is the universe capable of information and mathematical order at all? Now, there are several possibilities to these answers. Perhaps the laws of physics simply exist. They're brute facts. There is no deeper explanation. Perhaps there are infinitely many universes, each with different physical laws, and we happen to inhabit one capable of supporting life. That's the basic idea behind the multiverse proposals. Or perhaps there is some deeper mathematical necessity that makes our laws inevitable. These are serious possibilities, and I don't think we should dismiss them simply because we don't like their implications. But notice something they all have in common. Eventually, each explanation reaches some fundamental level where the questioning stops. This is simply the way reality ultimately is, and that's unavoidable. Every worldview eventually has to confront something fundamental. The real question isn't whether there is an ultimate foundation. There has to be one. The question is, what kind of thing makes the best ultimate foundation? And that's where my thinking began to change. The laws of quantum mechanics aren't a random collection of disconnected rules. They're elegant, compact, mathematically consistent, and as far as we've been able to test, extraordinarily universal. That mathematical unity has fascinated physicists for generations. Einstein famously observed that the most incomprehensible thing about the universe is that it is comprehensible. And the more I think about that, the more profound that statement becomes. Because stop and consider what we're actually saying. The universe didn't just produce stars and planets. It produced beings capable of understanding the mathematical structure of the universe itself. We didn't create the laws of gravity. We didn't invent the electron. We didn't decide what the speed of light should be. And yet somehow a collection of molecules on one small planet has produced minds capable of discovering mathematical relationships that describe the behavior of galaxies, atoms, particles, and even the structure of space-time. That's extraordinary. And I'm not saying this proves that the universe was designed for us. It doesn't. But it raises a question I don't think we should dismiss too quickly. Why is reality understandable at all? Why should mathematics describe nature with such extraordinary effectiveness? Why should the same mathematical relationships discovered in a laboratory on Earth also describe phenomena occurring billions of light years away? And perhaps most strangely, why should the human mind be capable of discovering those relationships? If reality were nothing more than an ultimately meaningless collection of events, there is no obvious reason we should expect it to be organized in a way that is both mathematically elegant and intellectually accessible to creatures like us. And yet, that's exactly what we find. We look at nature, and beneath the complexity, we discover order. Beneath the order, mathematics. And beneath the mathematics, relationships so consistent that we can use them to predict what the universe will do before we actually observe it. That doesn't prove a cosmic mind, but it does leave me with a question that I can no longer simply wave away. Why is the universe not only orderly, but intelligible? And why did the universe produce minds capable of discovering the mathematics by which that order is expressed? The equations tell us how things behave, but they don't necessarily tell us why there is a mathematically ordered reality to describe in the first place. So here's my thought experiment. Suppose you had to create a universe, not just fill it with matter. You have to establish every law that matter will obey, every mathematical relationship, every physical constant, every symmetry, every conservation law, everything. Would that task require only power, or would it require understanding? Would you need something capable of conceiving an elegant mathematical framework before anything physical existed? Think about the difference. Power can cause something to happen, but understanding is different. Understanding involves grasping relationships, seeing possibilities, recognizing consistency, choosing among alternatives, constructing an elegant framework in which countless parts work together. And that's what we ordinarily associate with a mind. Now, again, I'm not saying this proves that God exists. I'm saying it gives us a philosophical inference worth examining. Here's the distinction that's important to me. I'm not claiming physics proves God. It doesn't. I'm saying, given what physics reveals about mathematical order, an ultimate rational mind is a hypothesis worth taking seriously. And that's a very different claim. It's the kind of reasoning engineers use every day. We compare competing explanations. We ask which explanation accounts for the evidence. We look for unnecessary assumptions. And we ask which hypothesis provides the greatest explanatory power. For me, the hypothesis of an eternal, rational mind stopped sounding like mythology. It became a serious philosophical possibility, not because physics discovered God, but because physics revealed a universe resting upon profound mathematical order whose ultimate foundation remains unexplained. Of course, there's an obvious objection. If the universe requires a mind, who created that mind? And that's a fair question. But notice what happens when we ask it. Every worldview eventually reaches something that isn't explained by something else. Maybe it's the laws of physics. Maybe it's the quantum vacuum. Maybe it's a multiverse. Maybe it's mathematics. Or maybe it's mind. Something has to be fundamental. So the question can't simply be, what caused the ultimate reality? Because if something caused it, then it wasn't ultimate. The deeper question is, what kind of fundamental reality is most plausible? Is ultimate reality fundamentally mathematical, physical, necessary, impersonal? Or could it be fundamentally rational and mental? I don't think science has settled that question, but I don't think science has made the question irrelevant either. Years ago, I would have dismissed the idea of a cosmic mind without giving it much thought. Today, I can't, and that's not because I abandoned science. It's almost the opposite. I followed the scientific questions farther than I had before. The deeper physics has probed reality, the less it resembles a collection of simple mechanical parts, and the more it resembles a universe governed by profound mathematical structure. Now, that doesn't tell us what the ultimate explanation is. Maybe the laws are brute facts, and maybe some deeper necessity explains them. Maybe a multiverse explains why we observe these particular laws, or maybe the ultimate foundation is something more like an eternal intelligence. I don't pretend to know which answer is correct, but I can no longer dismiss that last possibility simply because it sounds religious. For me, the hypothesis of a cosmic mind is no longer an implausible idea that can be waved away without examination. It's one of the possibilities that deserves to be taken seriously. I'm Tom, and this has been The Skeptical Engineer. And if you followed my channel, you know I don't ask anyone to believe something because it's comforting. I don't ask you to accept an idea because someone told you it was true. I ask you to examine the evidence, challenge your assumptions, and think like an engineer. So let me leave you with one final question. If the deepest level of reality is mathematical, lawful, and information-rich, what is the most reasonable explanation for the existence of those laws? And are they simply brute facts? Are they the inevitable result of some deeper mathematical necessity? Are there countless universes? Or is there something more fundamental behind them? Perhaps an eternal rational mind? I don't think we should answer that question too quickly, but I do think we should ask it, because sometimes the most important discoveries begin when we realize we've been asking the wrong question. And again, I'm Tom, this is The Skeptical Engineer, and until next time, keep asking good questions.